So warm-up 11 for today. I'm doing a review of what we saw last week. So once again, the common mistake here that some of you made was you forgot to put a 1 on the OR, and you did not distribute the 2 there. So be careful with that. Once you distribute, it becomes in parentheses, and then you distribute to all these, bring all these down, and then start your multiplication, numbers with numbers. -4 squared is 16 times 5, that gives us 80. And then from there, you focus on your variables. All right, let's go to number 2. Number 2 is very similar, except that this one does not have any exponents outside of the parentheses. You guys notice that? All right, so let me make some room here. And I'm going to zoom in. Boom. Okay, there it is. So, there it is. So let's see. What is the first thing I asked you to do? Oh, yeah, put a 1 here, a 1 there, a 1 here, a 1 there. Okay. Do we have any exponents outside? No. So at this point, I'm going to focus on multiplying all the numbers together, just the numbers. What is -3 times 2? -6. So what is -6 times 4? -24, and we're done with numbers. Now we focus on the variables. X to the second and x to the -8. Do they have the same base? Yeah, so we write x. So what is 2 plus -8? -6, bless you. Now let's go to the y. Y to the third and y to the -3rd. Be careful with this one. Y to the third and y to the -3rd. Same base? Yes. 3 plus -3 is 0. That is correct. Write that in there. Okay? If you don't see it, write it out. This is 3 plus -3. And what is that? 0. Okay. Let's go to the z. Z to the first and z to the 5th. That becomes z to the 6th. Okay. We're almost done. You're saying, we're almost done? Yeah. Look at this one. Look at this one. Tell your neighbor what that is. See if you remember the rule of that one. We're focusing on this one. Don't look at the other one, just this one. Let's see, tell everyone what that one is. It's a 1. Any number to the 0 exponent is 1. So draw a little 1 right here. Here's a 1. There it is. That becomes 1. Therefore, what is 1 times -24? -24. What is 1 times x to the -6? X to the -6. And what is 1 times z to the 6? Z to the 6, and we are done. All right, let's go to number 3. Here he goes. Number 3 is scientific notation. They're asking us to write it in scientific notation. There we go. Make some room. All right. So look at number 3. All right. Is this scientific notation? No, we need 1 digit on the left side of the decimal. But where's my closest digit? Over here, the 2, which means I'm going to move the decimal to the right. How many times? 1, 2, 3, 4, 5. So my new number is 2.3 times 10 to the something. Let's see. How many times did I move the decimal? To the right, which is a what? Negative. So 8 and negative 5. What is 8 and negative 5? 3. So this is scientific notation. Is it coming back from last week? Yes? All right. Let's go over number 4. Do you guys see the invisible decimal? Yes? No, because it's not there. Here it goes. Well, now let me place it. There it is. Now we can move it. How many times? Twice? 1, 2. 3, 4, 5, 6. All right, so my new number is 7.956500 times 10. How many times did we move it? 6, and it's a positive 6. That's scientific notation. Are we there? All right, let's go to number 5. For number 5, this one, you should be able to remember the formula to find the area of this figure. This figure looks like a triangle. Tell your neighbor the formula to find the area of a triangle. All right, I heard a lot of people say base times height. Area equals base times height divided by 2. Yes? Or half base times height. I'm going to go with this one. So area equals, what is the base? 2 cubed, x to the 4th, y to the 1st, z to the 4th. Times, what is the height? 3 to the 2nd, x to the 2nd, y to the 4th, and all that over 2. Okay. A equals, so let's see. What is 2 cubed? 8, x to the 4th, y to the 1st, z to the 4th, times, what is 3 squared? 9x squared, y to the 4th, and all that over 2. All right. I'm going to go this way, just to save some space and simplify. So I'm going to focus on the numbers. What is 8 times 9? 72. X to the 4th and x to the 2nd. X to the 4th times x to the 2nd. Same base. What happens to the exponents? Add. So what is 4 plus 2? 6. Y to the 1st and y to the 4th becomes y to the 5th, and then z to the 4th, and all that over 2. So, area of the triangle, what is 72 divided by 2? 36, x to the 6th, y to the 5th, z to the 4th, and all that in units squared. Hands if you got that by yourself. Okay, not bad. Make sure if you didn't get these, you write them down. The reason I'm going over them on the first day of the week, because the rest of the week is going to be very similar. I just changed numbers and figures, and I want you guys to practice these on yourself, okay? All right, get a Cornell note in front of you. You do not need a Frere model. We're going to go a little bit faster today, and we're going to go straight to the property. So we do need to go through the objectives. So we're still on standard that has to do with exponents, okay? We're also looking at attending to precision. So when I'm asking you to give me definitions, make sure you're as clear as possible with your terminology. Objective for today, I can simplify exponential expressions using division property of exponents. Read together, 1, 2, 3. I can simplify exponential expressions using the division properties of exponents. This is very similar to last week. Is that correct? But there's something very, very simple that's different from last week's objective to this week's objective. So you never what's different on this one from last week. Jesus. Did you ever hear that? He said last week was multiplication, this week is division. So write that down at the bottom left. You don't need a Frere model because I'm pretty sure over the weekend you went home on Friday and you got home and then they're like, oh, come and have dinner. Oh, no, no, no. I need to finish my pop partay for mathematics. Okay, then go ahead and finish. I won't interrupt you. And then you guys studied the terminology, right? And what was the main concept last week that we started? Exponential expressions, right? And I'm pretty sure you wrote your nice Frere model at home by yourself. And that one's going to be due tomorrow, right? With your own examples. You don't need to write that down because you already have it. Steps are very similar to what we saw last week. Identify the exponential expression as a quotient of powers and power quotients. Last week, how many properties did we do for multiplication? 3. For division, quotient of powers or power of quotients this week. So today we're going to focus on quotient of powers, okay? There we go. Copy this down, please. Quotient of powers property. Quotient of powers property. Example Q. Quotient of powers property. Okay, writing utensils down. I'm going to go over the property. I'll have you guys talk about it, come up with a rule, and then you're going to come up with a definition. Here we go. Writing utensils down, eyes up here, focus please. Ready? Okay. I'll let you finish writing once we're done with the 3 examples. Here they go. Let's do 3 to the 6th divided by 3 to the 4th. Then we got x to the 10th divided by x to the 7th. Then I'm going to use x to the 5th divided by y to the 4th. Here goes the property. I'm going to stop talking. Eyes on the screen. Here it goes. Talk it over with your neighbor, see what's going on with that property. Okay, copy that, please. And then we'll elaborate in regards to the definition. And underneath that, make sure you write asterisk and a heart. Aww. Copy that. All right. So we got the rule, right? But what we do need is a nice definition for our quotient of powers property. Now, we already went over the structure of a definition last week. Is that correct? So I want you to get your notes out. I want you to look at the definition that we wrote for product of powers property. You guys gave me a definition. I want you to look at the structure of it, how you start it, what terminology do you use, and once you give the rule for the property, look at it. Look at the product of powers property. Product of powers property. It shouldn't take you long because you're very organized. And you know where everything's at. They should have an app on the phone instead of find my phone, find my home plate, find my notes. I should come up with that app, huh? Damn. All right, did everybody read your definition? Okay, now tell your neighbor a definition for today's quotient of powers property using that same structure. Talk it over with your neighbors, please. Definition for today's Okay, let's see. Get us started, please. Natalie, how can you get us started for today's property? Quotient of powers property says, okay, write that down, please. When dividing exponential expressions with the same base, comma, let's wait for the rest to finish. Man, that's a nice way to start the definition, right? When dividing exponential expressions with the same base, all right. Everyone, what do we do? You subtract the exponents. Period. 10Q. Okay. Now we're going to do some problems that are going to have more than one exponential expression and the numerator denominator. Some of you might have doubts for your simplification. What did I say last week? When in doubt, very good. When in doubt, factor out. So check this out. Look up, please. So let's say there was a student, I'm just going to say a random name, see, and I'm not, thinking anybody in particular. Let's say this one student named Audrey, and she had doubts on her simplification of 3 squared. And if she wanted to factor out, she would do this one would be 3 times 3 times 3 times 3 times 3 times 3. Do you agree with that so far? And this becomes 3 times 3 times 3 times 3. Do you agree with that? Yes. Question, what is 3 divided by 3? 1. What is 3 divided by 3? 3 divided by 3? 3 divided by 3? So what is 1 times 1 times 1 times 1? So this is a big 1. Get it? Big 1? A big, never mind. So does everybody agree this is a giant 1? Yes? And what do we have left? 3 times 3. What is 3 times 3? Does that work? Once again, when in doubt about the rule, factor out. Copy that, please, so you can have it as reference. Now, what we have here is a property. I'm just going to address it in passing really quick. But just to refresh your memory from last week we covered two properties, aside from the product of powers. 2 weeks ago, we covered the additive inverse property, which gave us 0. And also 7 plus 0 is the same number. So this was the additive inverse. This was the identity property of addition. Why identity? Because we said any number plus 0 gave us the same number. You guys remember that? Yes, Mr. Q. All right, good. Identity property of addition. Identity property of addition. You guys remember that? Good. Now look at this one. This right here is 3 to the second. All right. Times. What is this one? What is this one? Very good. And what do we get at the end? 3 to the second. Question. If this is the identity property of addition, tell your neighbor the name of this property. Rachel, if this was the identity property of addition, what is the name of this one? Close. Identity property of exponents, it's close. This one's called of addition because what's here? Tell your neighbor what this one's called. Everyone. Identity property of what? Multiplication, because there's multiplication involved. Very good. All right, with that said, I want you to do this one by yourself. I'm going to forward you the screen, lock it, and you can do it on your iPad. Forgot to press record. All right, so we see that this becomes this because the reciprocal inverse. So let's do one more. What if I had b to the negative 8? That becomes what? 1 over b to the 8 because of the reciprocal inverse. Everybody got it? All right, so with that said, copy those on your paper. Example 1, C, and D. We got m to the 5th, n to the 4th, parentheses, m to the 5th times, raised to the 2nd power to the n. And then we have 3 to the 5th, 2 to the 4th, and 4 to the 3rd over 3 to the 4th, 2 to the 2nd, and 4 to the 6th. See what you get. Copy that and go. Okay, let's do this one together. Example C. On example C, does everybody see that there's a parentheses with an exponent outside? All right, let's do that one first. Let's simplify this. So what do we do here first? Multiply 5 times 2. So this becomes what? M to the 10 and n to the 1. That is correct. Bring the m to the 5th over and n to the 4th over. Okay? I'm using red now. Are these the same base? Yes. What happens to the exponents now that we're dividing? Subtract, so it becomes what? Negative 5. All right. Are these the same base? Yes. What is 4 minus 1? 3. So which one's the only one that we're going to do the reciprocal inverse? M over 1, right? So this becomes what? 1 over m to the 5th. And which one stays in the numerator? N to the 3rd. You're like, what? Yeah. Okay. On the home plate, yes. I want to see the reciprocal way. By the way. Yay. Okay, you're doing D by yourself. See what you get? And let me see, I'm going to need, Omari, help me hand these out, please. It's only progress reports. Yay. And oh, help me with this one, please. Let's get started. Gerard, this becomes 3 to the what? 3 to the first times. This becomes what? 2 to the second times. This becomes what? 4 to the negative third. All right? Hands if you're up to right there. Okay, good. Tell your neighbor which is the only one of those that we're going to do the reciprocal inverse. Which one? Four to the negative third. That is correct. If we put a 1 like this, this becomes what? 1 over 4 to the third times. What stays on the numerator? 3 to the first and 2 to the second. Are we there so far? Yes, Mr. Q. All right. Let me make some space here. Next. 1 times 3 is 3. What is 2 to the second? So what is 3 times 4? 12. And this is 4 times 4 times 4, which is 4 times 4 is 16 times 4, that is 64. Can we reduce this a little bit more? Yes. To what? Yeah, but this is a proper fraction, so it's not an improper. So can we reduce this anymore? Very good. We can divide by 4, divide by 4. Therefore, 3 over 16. Yes? Yes, Mr. Q, we love this. Good. Home plate for tonight. Odds on 7.1 and numbers 1 through 12 on 7.2 play sheet. If I call your number already, you turn in your iPad, you may leave. Have a good one. Enjoy your home play. See you guys tomorrow. Bye.